The next part of our lesson is using synthetic division to divide. Synthetic division is a shortcut and it's an alternative to long polynomial division, but it only is applicable when you have a linear factor of the form x minus c. If you're trying to divide by an x squared minus c, you cannot use synthetic division. So first of all, it's only for linear factor division. You cannot use it for any other type. If it's any other type where you're trying to divide by a quadratic or a cubic, such as the ones here or the one there, you cannot use that. You'd have to use long division. So then you're forced to that method. Synthetic division, I think you will like. It really shortens up the work that you have to do. They give you some examples here of what the long division looks like, then they suppress the variable, collapse it vertically, and then they finally show you the synthetic division. I'm going to go through this process of synthetic division and show you how it works. Here's a step-by-step algorithm if you want to look through that process. If you get lost in any of this, you can always look through that. But when we get done, what we're going to do is we're going to figure out how many times this x minus 3 goes into this polynomial, and what we get is a depressed polynomial. So we've really reduced it by a power of 1. If you take out a linear term out of an x cubed term, we should always end up with an x squared factor left. So that's what we're going to be looking at, is a depressed polynomial, which should hopefully help us factor in the end. And you'll see the big picture of all this. These techniques are really trying to help us find ways, finding factors of larger and larger polynomials so that we could factor them and find their solutions. So synthetic division. To start the synthetic division, you want to make sure that your number that you're dividing by is in standard form. Make sure it goes in order of the powers, and this one is, it's going x cubed, x squared, x, then x to the 0. If there's any of these powers that are missing, and in the previous problem, and flash back to that one just quickly, we had one that was missing. We had the x to the 5th, x to the 4th, but we did not have an x cubed. So we had to leave a placeholder in there of 0. Same idea and concept is going to happen on our example in part B. It doesn't happen in part A because all of them are there. But if they're missing, you're going to have to put a 0 in there. Okay, and we're going to divide this by x minus 3. One of the biggest changes in the synthetic division is, instead of using x minus 3 as your divisor, you're going to use what they call the related 0. So x minus 3 is the factor. What is the 0 of the function? So the related 0, what they're talking about is taking this linear factor and solving it for x, and that is 3. It's always going to be very simple to do. No big problems on doing that. So synthetic division basically takes the coefficients out of each and every one of the numbers in the dividend. So I want to place a 4, 3, -1, and an 8. We don't use the traditional division bar. What we use is a little inverted division bar maybe. You put your 3 out in there. This is the related 0 to the factor that you want to divide by. Remember, that's a major change. The next thing you probably want is a line that goes across there to separate your addition and subtraction. So here's how the process works. In order to get this started, you first drop down your first number. Every single time this first coefficient gets dropped down, so 4. Now it's a matter of multiplication and addition. So we take this 3 times that 4, and that's 12. We put the number underneath the 3. Now we're going to add. It's always addition on this, so 3 plus 12 is 15. Now we're going to multiply it. So multiply 3 times 15 is 45. Put the 45 in here, and we always add. So now it's going to be 44. We take the 44 times the 3. 44 times 3 is 132. Now we're going to add. So 132 plus 8 is 140. That's our last number, so we're done with our division. So we're going to try to write out our polynomial that we just got done creating. This 3, remember, is related back to the factor of x minus 3. And part of what we're trying to do is just use synthetic division to factor. So we have a factor of x minus 3. X minus 3 went into our original polynomial. And this is where you got to concentrate a little bit. This thing here is your depressed polynomial. Now, depressed means this was x cubed, but when we took out a power of x minus 3, we really took out a linear term, then this is going to be a power of x to the 4th. So this number here will always be 1 power smaller than what you started with. So it'll be 4x squared, then plus 15x, and they're going to go in order now, plus 44, with a remainder of, so plus, this thing here represents our remainder, 140 over our divisor, which was x minus 3, parenthesis. So using synthetic division to find how many times x minus 3 goes into our original polynomial, it didn't go in there evenly, but this is what represents the division that we were asked to do. So first round of synthetic division. We'll practice again in another example. Okay, in our second example, we have 6x to the 4th plus 11x squared minus 11x squared minus 12x plus 7. We're going to divide it by 3x minus 1. Okay. So we're going to tackle that in just a moment. I got to catch the door here. Okay, priority number 1 is to make sure they're written in standard form. We've got a 4, 3, 2, 1, 0, so they're all in order, so I need to pull out a 6, an 11, a negative 15, and then I want to pull out a negative 12, and then pull out a 7. The divisor that we're going to divide by, and this is where we got a little bit of a twist in this, it's 3x plus 1. So all I got to do is check, is it linear? And this is linear because it's to the first power. So I want to find its related 0. So the related 0, I can find that very easily by saying, what is 3x plus 1? Set it equal to 0, since that's the related 0. And we got 3x equals a negative 1. That means x equals a negative 1/3. Now this is what we're going to divide by. This is the related 0 for this factor. So that goes out in front, negative 1/3. Don't forget that you always have to have the 0 for our factor in order to use our synthetic division. Okay, I'm going to bring this line in here, stretch it out a little bit. So now we go through, and the very first step, we'll always bring down the first number, which is a 6, and now we have to take negative 1/3 times 6. So this is 6 over 1 times a negative 1/3. It's going to be negative times positive, which will be negative, and then we take a third of 6, which is going to be 2. Now we add. We will always add on these. 11 plus a negative 2 is 9. So now I got to take the negative 1/3 times 9. So now it's going to be 9 over 1 times a negative 1/3. And again, it's a positive times negative, so it will be negative. And the 3 will reduce into the 9, and that'll give us 3. So negative 3. We'll have a negative 15 plus a negative 3, which is a negative 18. And now we've got a negative times negative, which will be positive, just to emphasize that. And what's a third of 18? A third of 18 is 6. So now we add. Negative 12 plus 6 is a negative 6. We got a negative times a negative again, so it'll be a positive. What is a third of 6? Well, a third of 6 is 2. We add and we get a remainder of 9. We're out of numbers, so we're done with our synthetic division. So we write our related 0 back as a factor, which was 3x plus 1. So 3x plus 1 times, now this is the remainder. The rest of this represents your depressed polynomial. Depressed means it gets 1 degree lower. So this was x to the 4th. So we start off with 6x to the 3rd. Remember, we divided by x, so that should bring the power down by a power of 1, which it is, 6x cubed. Then plus 9x squared minus 18x minus 6. Now we have our remainder, so plus 9 over 3x plus 1, parenthesis. That is synthetic division at its finest. It's fast, it's efficient. It's a much better alternative to long division. And once you get that system down, dividing by linear terms is fairly simple.